Okay, so Mr. Ops here, and today we're going to be evaluating logarithms. And so if you see here, I have this graph here of y equals 2 to the x, which is y equals 2 to the power x, and I'm going to do these problems. But in order to do it, I want to first introduce the idea of if I take my value x, and I take x and I put it onto the exponent, okay? I put it on the exponent. This is called making an exponential. So I put on the exponential means the variable goes into the exponent. And so this is the function that I've created, y equals 2 to the power x. So I've put on the exponent. Okay, and so if I take a look at a part, I want x to be 3 and to find y. Well, that's easy enough to do. I can just make this 3, and I get y is equal to 2 to the power 3, which is simply 8. And so if I look at this, when x is 3, I can clearly see that y is 8. Easy peasy, no problem. All right, and so let's try the next one. Let's go the other way. So now y is 2, so 2 is my y value, is equal to 2 to the power x. Well, it's clear for me to see that there is a 1 on this exponent, and this is the x, and so in order for them to be equal, x has to be 1. And so if I consider y equals 2 graphically, I go from y equals 2, and I go down and I get 1. So there's a graphical approach, no problem there. All right, so let's try the next one. If I have y is 3, 3 is equal to 2 to the power x. 3 does not, I can't convert that to a base of 2 anyhow. So then if I go here on the graph, I can go from 3 over to here, and it's not a nice value. I don't really know what to do. So I could go one other place and go to my calculator here and try and see what I can do. I can go 2 to the power of, well, looking at my graph, I can estimate that as 1.5. Well, that's not quite 3. Well, let's try bigger. Let's try 2 to the power of 1.6. Oh, that's too big. So I could do this for a really long time. 1.55 we'll try. Well, and that's getting closer. So there's got to be a better way. And of course there is, or I wouldn't be doing it. This would take me forever to do. And so the other way that it is mathematicians invented this thing called logarithms. They're going to take this and they're going to rewrite it. Okay, they're going to convert to a logarithm. All right, and so what a logarithm does is it takes log and it considers the base of 2. Here's my base 2. So I put a little 2 here. This is a subscript. They're both bases. And then I also put the 3 here. And that is going to equal to x. Okay, and so this says 2. So it says 2 to some power x is 3, or 3 is equal to 2 to some power x. Okay, and for me to remember this all the time, I always remember that the base is always the base, and then the x switches places with the 3. Okay, it's no longer, the 2 doesn't have the x attached to it, they switch places. And this I can evaluate with my calculator. If I go to math, and if I scroll down, or I go up is faster actually, I'm going to go to this thing called log base. And I'm going to have a base of 2, it's a subscript, and 3. And that is 1.58. And so if I go 2 to the power of 1.58, I know I'm going to get 3. And so here I know that x is equal to 1.5849, blah, 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 forever. Okay, and so I can use this idea of logarithms to solve exponential equations. And so the one thing that I want to highlight, that these two expressions are equivalent. This is really important, okay? So if I'm going to have b to an exponent x is equal to, let's say, m. Well, that's the same thing as me saying that log, I'll make the b purple, to some base b, m is equal to x. These two statements are equivalent, and it's a matter of just rewriting with the base stays the same. Remember that this base and this base are the same. The exponent moves to the other side of the equal sign, and m moves to with m together. All right, that's an important thing to remember. So there's a little bit of theory and reasoning behind a logarithm. We'll do some practice in the next video.